good day all, and welcome to this session titled What's New in the Robotics Portfolio, which is being presented by Tony Carew. Tony is our DELMIA Senior Portfolio Specialist for Robotics domain. And in this session, Tony will be sharing with us new features in the robotics domain as well as the technical updates. So before we start, we would like to revisit DELMIA's Sustainable Operations Framework. And some of you have already seen this from our CEO Guillaume's session, and few others have also presented this. Sustainable Global Operations, which focuses on people for defining workforce of the future. It talks about Planet, which enables virtual twin experience, which is partly covered today by the robotics domain, and Profit, which is all about value network orchestration. So we believe these pillars are critical to manufacturing success in what many are terming this as new normal. And we also believe they are best delivered through 3D Experience Platform and, of course, DELMIA Solution Portfolio. So with this introduction, I would like to hand over the session to Tony. Tony, the session is yours.
Good afternoon, everyone. It's my pleasure to be here and to present to you all what is new in the robotics portfolio. There are a lot of new features and functions that I can show you today. I'm very excited to show you what's new in the portfolio and some of the tools that we've been working on. So before I begin with what's new and the new highlights in the robotics portfolio, I'd first like to do a quick overview of the product portfolio for robotics and how the portfolio is architected. So to give you just first an overview of the products that we'll be seeing today, at the base of our functionality, we have the product called Robotics Engineer. And so this is the base product that we have our add-ons to, where you add on applications or you add on different functionality. And so the Robotics Engineer has the core functionality for doing robot simulation, and it also has capabilities for robotic material handling and packaging applications. So as the base role, we then branch out to the different applications for robotics. And so in the upper left corner, you'll see that we have the Robotic Spot Engineer. And this is the application-specific role that we add on to Robotics Engineer, and this is for doing spot fastening applications. So there are tools in here for doing spot welding, and there's also tools in here for doing drilling and riveting. On the other side of the screen, you'll see that we also have a product that's called Robotic Surface Engineer, and this role is for creating robot paths based on a surface. And basing robot paths on a surface is applicable to different applications for robots, such as painting, shot peening, and flaming. On the bottom, you'll see we have the Robotics Arc Engineer role. And this role is for performing robot tasks that apply to arc welding, laser cutting, and sealant deposition. And this is the role where we create robot paths, and this is based on could be on a curve or on the intersection of parts. Okay, so after the applications, we have other extension roles that help to improve or extend the applications into more functionality, such as if you wanted to do robot offline programming. The Robotics Offline Programmer gives you the option to take your simulated robot and create a robot program in the native language for the specific robot that you're using. The Virtual Commissioning Expert for robotics is so that you can do virtual commissioning of your robot work cell and have it driven by a control system like a PLC or a PLC emulator. A new role called Robotics Optimization Expert is a role that we're going to introduce in just a minute, and that is for automatically creating collision-free robot trajectories. We're going to talk about that in just a second. So what's new for DELMIA Robotics? Okay, so this is a brand new role that's called Robotics Optimization Expert. And what this role does is, this is a role that has an algorithm that will create a collision-free robot trajectory based on what the user inputs. So here we have a robot a set of fasteners on a piece of geometry that the robot is moving to. And as you can see, there are collisions involved because there are no via points. So the user can input the different motion type, the accuracy, the speed, the robot interpolation, the sampling distance, the position, the orientation, as well as the search range. And this function will return for the user a collision-free robot path. So it will insert the via points in between the fasteners so that the robot can move through the trajectory collision-free. The neat thing about this function is that once you perform the study and invoke the command, you are able to save those search parameters. So once you input all the information, the parameters to operate the function on, it will automatically save those parameters. So in the event that if there is a design change, you can recall that exact same study that you ran and then rerun it again when there's some kind of a change in the work cell. The next set of capabilities I'd like to talk about, and this is in the robotics offline programmer role. And we introduced two new robot translators in robotics offline programmer. The first one is for Kobelco robots, and the second one is for Universal Robots. And both of these companies are extremely well known in the robotics industry, and we have created translators that will translate your simulation into the robot's native language for these two robot brands. These translators are bidirectional, so you can not only download to these robots, but you can also upload from the production robot. These translators leverage more than 15 robot models of Universal and Kobelco robots that are included in the DELMIA robot library. They also have, these are among the 13 translators that we now have for robot programming, and they support this over 1,700 robot models in the DELMIA robot library today. This next development, this is a very exciting development because we've never really had this before, and this is something that's brand new and in the industry is also brand new. And this is being able to simulate the emergency stop inside of a robot simulation. So as you know, we have the robotics, we have the validation or the virtual validation of the work cell. And what this allows you to do is to validate the work cell in terms of an emergency stop. So as the robot goes along its path in the simulation, we are able to define an input in the simulation that can be triggered by another device in the simulation, or it could be triggered by an external device such as a PLC or a controls emulator. And what this does is, so when we simulate the robot path, we can name the I/O that the e-stop gets triggered on. We can give it a stop time, which is how long it should take the robot to come to the stop. And then we give it a mode with which to stop by. Should it go to the next point when it restarts, or should it go back to where it came from when it restarts? And so what this enables us to do is when the signal is fired in the work cell, we can simulate a deviation in the tool point of the robot when it stopped during its path. So this helps to validate the safety of the work cell and it helps the user identify some of the issues that may be occurring with the emergency stop. So the next set of capabilities is defining robot software limits. And the software limit in the robot is basically identifying where the robot's envelope should stop. So in other words, if I program a robot path and I'm using a particular area of a robot joint that it's going to use, say that my welding path makes joint 1 travel from -90 to +90, I can input software stops just outside of those two limits. And this software limit allows the robot to shut down before it hits a hard stop. And so this helps it decelerate so it doesn't just knock the hard stop off of joint 1. And so what this does for the user is it helps the user identify and helps the user to be conscious of where the software limit should be. And identifying where the software limit should be also helps you identify where the robot hard stop should be. So this lets the user be conscious of the robot's working envelope and helps them to implement the safety standards that are dictated by the manufacturer. So here we see moving the robot through its joint limits. And so where we have software limits set up, where pink is the farthest limit and orange is the software limit of the robot joint. The next capability is enhancements that we've done to the teach command. And so when you're trying to perform operations on paths, it's a little bit cumbersome sometimes to be in teach and then have to leave the teach panel to go and perform an operation on tag points. And this is a really neat set of features because it really saves you the user a lot of time in operating on tag points. So what we're looking at is inside the teach panel, we can select individual robot locations inside the path. In other words, I don't have to operate on the entire robot path. I can perform operations on individual tag point locations. So operating on tag point locations, I can transform them so I can move them in X, Y, Z or rotate them in roll, pitch, yaw. Or I could take those locations and I can mirror them. I can copy and paste them and move them around. So it really, really helps the user save time because you don't have to exit the function to modify the path. Another set of capabilities that we've modified since we're talking about the teach interface, what we've introduced is a method to modify the individual columns. And this modification is a lot like Excel. So in other words, we have columns inside of the teach interface. And what we've done is we've made it more like Excel because when we can take a column now and we can freeze that column. So in other words, when we're scrolling left and right in the teach interface, we don't see, we can just lock down the robot motion or the name of the locations, for example, and then scroll left and right, and this column will be locked. We also have the capability to individually change any one parameter in one of the columns. So we can multi-select and type in a different value for it, and we can, and it will basically, it treats it like it's an Excel spreadsheet. The next improvement that I'm going to introduce is, this is in the efficiency gains that we are experiencing now in DELMIA Robotics on a 3D Experience platform. And these improvements are made to speed up the calculation of the software while we're performing different types of studies. So, in other words, when you're doing a dynamic clash analysis, for example, and if you're not familiar with it, dynamic clash means you turn it on and it just looks for everything that's colliding with the moving objects. And so there's a lot of calculation that goes into it. So what we've done is we've enhanced the software so that it's faster at calculating, because what we're doing today is we're making it a lot smarter about disregarding geometry that should not be considered while it's calculating the collisions in the simulation. So that's the first point. The second point is that we're taking better advantage of the multi-threading that's available to us today. So we're taking full advantage of the multi-threading capabilities, and that's also helping us speed up the calculation and speeding up the performance. So on the left-hand side of the screen, you can see that the calculations for the collisions are extremely slow and it's very choppy. But on the right side of the screen, where we've made the improvements in efficiency, you can see that the simulation is chugging right along, and it's moving much faster than the screen on the left. And this is way, way better than what we had before. It's also better than what we did in V5. Frankly, we surpassed the performance that we had in V5 a long, long time ago. And this is even better than that. This is better than what we were doing. So this is an important gain that we have. Okay, so we're going to move into the drilling and riveting domain. And I'm going to talk about escape zones and rivet zones. And before I tell you about the improvement, I need to kind of explain to you a little bit about what it is I'm talking about. So I'd like to explain, so when a robot goes to a rivet or a pattern of rivets, in the aircraft industry, they're putting them in zones. And so you can have a pattern or several patterns inside of a zone where the robot is riveting, but then to lay to put the layers of the aluminum down and have them lay the way that we need to, we don't always do it in a single area. Sometimes when it's riveting, you may want to have the robot move to a different pattern of rivets on the other side of the panel, for example, so that the panel lays correctly. And so what this is so if you have a set of rivets in zone 1, you cannot just move to zone 6 because there are things in the way and you have the danger of a collision. And so what this is a system to safely move from zone to zone. And so if I want to move from zone 1 to zone 2, because they have the same escape zone, number 11 in this example, you can move from zone 1 to escape 11 and then move into zone 2. However, zone 2 has a parameter set that says that it's safe to move to zone 1. So it can move directly to zone 1 because of that attribute. If you look over at zone 5, for example, zone 5 is safe to move to zone 4. So it can move directly to zone 4 from zone 5. However, if you wanted to move the robot from zone 5 to zone 3, you would have to go to escape 13, and then you'd have to go back up to escape 1, and then go to escape 12, and then you would be able to go to zone 3. And this helps with identifying, it helps the robot move around from pattern to pattern of rivets. So what we've done concerning this is we have improvements in the waypoint functionality, and we're giving the user the ability to change the waypoint, the escape zone, and the safe zones for the drill and rivet operations. So what happens is we've given check boxes for the motion type for the fastener and its type. The robot task is going to be updated whenever you make a change to the waypoint parameter dialog. Also, while creating a task, Non-leaf waypoints can be selected as a parent waypoint when you're assigning a parent waypoint to process points. And while creating the task, the waypoint operation is created with the appropriate motion type, and that's based on the selected parent waypoint. The next set of capabilities is, this is actually a two-in-one kind of an enhancement, because there are two things that I'm going to talk about. Okay, so the first part is that we are now able to export a work cell state or simulation state as a CGR. But the second part is that we're able to use that in factory issue management to create an issue and see it to resolution. So as you probably already know, a simulation state includes the visibility of objects, the color of objects, the location in the work cell, the home position or whatever position it's in at that point, and things like that. So when we export that as a CGR, we can include it in manufacturing issue management. And what manufacturing issue management is this is a web-based application, and where we're able to identify issues, we're able to assign them to groups, we're able to suggest resolutions, track them to resolution, track what the resolution was, and take the CGR that we've created and associate that with the issue that we created in manufacturing issue management. So this is a system where we can create the issues and we can better communicate the issues that we're having with all the individual stakeholders, as well as the different engineering disciplines that we might be working with. So once you create the CGR in issue management, you can also mark it up. You can also draw circles and you can write on it and things like that. So it's a very powerful tool. The next thing I'm going to talk about is dynamic cycle time. So dynamic cycle time calculation for robotic spot engineer. And this is the calculation that the software will do every time, whenever it sees a fastener. Because we have the thickness of the materials and the layers that a rivet is fastening, what we're able to do is to adjust the drill and rivet time that's being used and apply that to the cycle time instead of having the user input it. And so what this does is this basically takes the engineered stack up or the engineered thickness of the layers and allows us to apply it to the individual fasteners. And so when the fastener is simulated, when the robot moves to it, it uses those values and applies that cycle time so that as it goes through its entire robot task, the cycle time has been calculated automatically and we don't have to depend on user input. If we do depend on user input, a lot of the times there are silos of knowledge within the company where some people know this and some people don't know what values to apply. So it makes for a more accurate simulation. Tool analysis. Some of you may know that we have a tool that's called tool analysis. In the automotive body and white industry, what we're doing is we take the robot weld guns and we show the fasteners to the software. We show a catalog of weld guns, and then we tell the software, go through this catalog, take each weld gun, put it on each fastener, and rotate it around, and tell me which weld guns are capable of doing which fasteners, and then it brings me a big spreadsheet. Well, we're now applying the same technology to drill and rivet guns. So the tool search command can now be applied to catalogs of drill and rivet guns. And it's the same scenario where it will take the drill and rivet gun, it will see that it's capable of doing that style of fastener or that pattern. It will then use collision detection to make sure that it is able to do it collision-free, and then it will present the results of which drill and rivet guns will apply to which fasteners in the given scenario. Moving into Robotic Surface Engineer. This is a tool where sometimes when you're creating something like a paint path and you don't want to pay attention to the individual intricacies of a surface. In other words, it might be like the side of an engine block, or you're trying to paint it, and there's a lot of features there, but you don't really care that much about the features. You really just want to paint it. Okay. So what this feature allows you to do is create a virtual plane. And this method of creating a virtual plane is based on a curve. So if design has given you a curve that you should create your paint path on, or you create a curve, what it allows you to do is to take that curve and extrude the curve and create a virtual plane. And when that virtual plane is created, you can then create the robot trajectory for painting the surface that's behind that virtual plane. Template-based kinematics definition. This is interesting because a lot of the times when you're creating kinematics, you may have some experts in your company and they're very good at it, and you may have some people who may not be as good at applying kinematics. Further, you may have very complex mechanisms that you're applying kinematics to. And so what we're introducing is applying kinematics, but we're going to use a template-based kinematic definition. So what this is basically, as you identify the different parts, and we've used color coding of the individual parts, we're going to take that same concept and we're going to apply that to the template. So in other words, I can identify the base, the cylinder, the rod, etc., the clamp arm, and identify them in a template. So when I identify the template and create the template for a specific type of a device, I can then save that. And it's an XML file where you can edit it. And I can save that template and then reuse it for other devices that are of the same type, which makes it very, very simple for someone to apply complex kinematics and basically helps them, guides them right through the process step by step to make it easy to do. Okay, let's move into Plant Layout Designer. This is a virtual markup tool. We now have a new way to create floor markups and to make it easy to identify the individual areas of the shop floor. So these are kind of like little stickers that you can apply. You can design what size they are, what shape they are, place them around using the compass. You could identify a workstation, the direction of the traffic, whether it's watch out for forklift traffic, could be safety, etc. And then you can place the marker, change the color of the marker, you can change the text that's on the marker, etc. So it really helps people understand what your layout is communicating. So once you create them, you can save them off so you can reuse them again and again. The other thing is you can apply a font style as well. So you can pick a font to apply it. Okay, so that's everything that's new in the robotics portfolio. If there's anything that you've seen here that you want to have more information on, you can request a demo from your Dassault System sales rep or from your sales partner representative. Okay, so since I have just a little bit of time left, I'd like to quickly show you a little bit about what's coming up. So what's going to be next? Here's a little something in plant layout. As you know, probably know that we support the import of cloud points, okay? And so when you're importing a large amount of cloud data, there's also a file format out that's called E57, and it's a subset of XML, and it's better at supporting large amounts of data, and so we will be supporting that soon. There's another surface trajectory function. Remember I talked about painting complex surfaces. Well, when you created your trajectory, it kind of gives you just a single spacing all the way across the surface. Well, now we're introducing the ability to modify a surface trajectory, and that means I can take a section of a trajectory and insert more trajectories inside of that trajectory. So I can insert more tag points. I can insert more trajectories going back and forth, so I can space them differently inside of a certain area. I'll be able to position the tool differently, so I could change the tool orientation from stroke to go backwards or forward or whatever orientation I want. And I can modify the positions of the process tags. So that's a neat development that we're working on. Also coming soon, new robot translator. Yes, we're going to add another robot translator. This one is going to be for Mitsubishi robots, and of course this will be bidirectional and will create Mitsubishi native robot programs from the robot tasks that you're simulating in 3D Experience. And that's everything that I have today, so thank you so much for listening, and thank you for your attention. Thank you.
The first question in the order they came in, does robotic optimization expert ROS role uses the optimization capability of DELMIA Quintic?
Okay, it's a good question. I can't be certain about that. I do know that it was a special development at Dassault System. It did include multiple R&D sites at Dassault, so it wasn't purely a single R&D lab that came up with that solution. If you want to email your question to the email on the screen, I can address that later to get more details on that if you'd like me to.
Thanks, Tony. I think that involves, as you rightly said, some multiple information coming from R&D labs. Okay, so moving on to the second question, even though we are on a 3D Experience application session here, the question is on V5. Which of the new capabilities are available in CATIA V5 environment? Tony?
Okay. Well, the CATIA V5 environment is completely different than the 3D Experience environment. All the developments that I've talked about today, I would say virtually none of them are available in V5. But being that they're two separate developments and two completely separate environments, that would be a completely different conversation that we'd have to have as far as what's new in robotics in V5. So that would we'd have to take that offline.
Yeah, thanks, Tony. This is a 3D Experience application session. I think we will answer you back on the V5 improvements. Then moving on to the next question, Tony, is it possible to change tag reference from Teach panel? And the comment here is that the improvement has been really appreciated.
Yeah, no. To my knowledge, no, you cannot change the tag reference in the Teach panel right now.
All right, that was quick. Thanks, Tony. And any idea when the new surface trajectory functions will be introduced, both on-premise and on cloud?
The
surface trajectory functions.
When they will be available, I'm sorry, read the question one more time for me, please.
Yeah, any idea when the new surface trajectory functions will be introduced? Which release, both on-premise and as well as on cloud?
Okay, so they are available on cloud when they are available GA or on-premise general availability. So when they're available on-premise, they're also available on cloud. The first set of enhancements to trajectory, being the virtual plane, is available in 2020X, and the second surface trajectory enhancement that I showed you, which was the insertion of the surface trajectories inside of an existing trajectory, that one is 2021X.
Awesome. And there was a question on the recording of this demo. The question is very useful demo. I would like to know when the recording is published. Now, if you can be, enrolling yourself into DELMIA Robotics community, you will find the complete recording on that community site. All right. Moving on to the next question about virtual commissioning. That's your favorite topic, Tony. What about virtual commissioning? Any news on that? RTS and virtual commissioning working together?
Well, the news, as you all know, is that we use control build when we're doing our virtual commissioning. And so we're working right now currently to move those two tools closer together by having them on the 3D Experience platform together. And so that is not available yet, but that is something that we're moving toward right now.
Thanks, Tony. Thanks for that answer on control build. There were a lot of questions on control build. Pretty much you have actually answered it. There was a question slightly off the topic. What is happening with ABB? Where is our partnership shaping up?
Well, our partnership with ABB is, it gives us an opportunity to really capitalize on ABB technology, but also realize that we are a robot brand agnostic simulation tool. We're working closely with multiple robot vendors. We have projects that are ongoing with Universal Robots, with FANUC. So we have a lot of different developments going on and different projects going on with all the robot vendors that we work with.
Awesome. There's one question on DELMIA 3D Experience. Are robots available with the dress pack mechanism? Do you know this, Tony?
Which dress pack mechanism? We don't really offer dress pack mechanisms. I mean, there's all kinds of different dress packs that you can outfit a robot with. Things like Leone has different ones, and FANUC has theirs, and there's some available from other robot vendors. So it's kind of a niche market, and it's also there's a lot of variety in that market. So there isn't a single one that we are supporting right now.
All right. I think we've almost come to the end of the session. And there is one question from our partner community. This recording, we will explore whether we can publish in the partner community, and we'll come back to you later. As we are almost coming to the end of the session, if there are no more questions, I think yes. I think we have no more question. Thank you very much for joining the session of the DELMIA Community Summit today, and we hope you found it valuable on the robotics part. Please visit the event website as you're seeing in this slide in order to register for other sessions of your choice. You may find it interesting, and or you can also send us an email at delmia.cs2020@3ds.com. Once again, thank you all for your attention, and you have a safe and good rest of your day. Thank you very much.